Newton's first law of motion states that each body moves at a constant speed in a straight line unless a net external force acts upon the body. Thus, if an object is moving about a circle, even at a constant speed, then there must be a net external force acting on the object, and the object must be accelerating. This is called centripetal acceleration. In today's lab, a rubber stopper is connected to a string, and the rubber stopper is swung in a horizontal circle. The tension in the string causes the stopper to undergo centripetal acceleration. The objective of this experiment is to investigate the centripetal acceleration of the rubber stopper. For this experiment, we needed string, scissors, glass tubing, a meter stick, safety goggles, a timer, 2 gears, a Bunsen burner, an igniter, a gas valve, a rubber stopper, a paper clip, a phone to record and take pictures, a pen, and a notebook. We predict that the centripetal acceleration of the rubber stopper will increase as the distance, the radius, between the rubber stopper and the tube increases. Adding an extra weight, an extra gear, will make a small difference in the centripetal acceleration of the rubber stopper. First, the gas tube was cut to a length of 12 inches. Then, the rubber part of the Bunsen burner was plugged into the gas valve. Next, the gas was turned on. Then, the igniter was placed above the Bunsen burner. Then, the igniter was struck and the burner was lit. The end of the glass tube was placed in the fire for 5 minutes. After those 5 minutes, the other end of the tube was placed in the fire for 5 minutes as well. The glass tube was placed on the table to cool for a few minutes. 80 centimeters of string was cut, and then the string was passed through a glass tube. The rubber stopper was fastened onto one of the ends of the string. The string was adjusted so that the distance between the rubber stopper and the glass tube would be 5 centimeters. On the side opposite of the rubber stopper, a paper clip was attached to the cord just below the tube. On the same side as the paper clip, 1 gear was fastened to the cord. The glass tube was held and the rubber stopper was rotated 20 times. A phone was used to record how much time it took for the rubber stopper to make 20 revolutions. Another gear was added, which made the mass on that end of the string heavier. Then, step 14 was repeated, except there was now an additional gear. Trial 1 had 1 gear and a 5 centimeter radius. Trial 2 also had 1 gear, but this time it had a 10 centimeter radius. Trial 3 had 2 gears and a 5 centimeter radius. Trial 4 also had 2 gears, but this time it had a 10 centimeter radius. As you can see, there were a total of 4 trials. The first 2 trials are using 1 gear, which is a total of 12 grams, while the third and fourth trials are using 2 gears, which is a total of 24 grams. The first and third trials have a radius of 5 centimeters, and the second and fourth trials have a radius of 10 centimeters. As you can see, the times clearly show that Trial 1 and Trial 3 have the fastest times because the radius was shorter, whereas Trial 2 and Trial 4 have the slower times because the radius was longer. In this chart, you can see that we laid out each of the trials, along with their velocity, centripetal force, and centripetal acceleration. As you can see, the ones with the greater times have greater accelerations and forces, since those factors are directly proportional. That would be Trial 2 and Trial 4. And those with smaller times have less acceleration and force. That would be Trial 1 and Trial 3. We did the experiment and were able to investigate the centripetal acceleration of a rubber stopper. We also found the centripetal force to show what caused the stopper to move in a circle. The hypothesis made prior to the experiment was proven true. The centripetal acceleration of the stopper did increase as the radius increased from 5 centimeters to 10 centimeters. Additionally, the gears did slow the stopper. As for the recommendation, first, make sure the person lighting the Bunsen burner knows how to work the igniter before turning on the gas. Second, take videos of everything. Third, write the procedure as you do the experiment. Fourth, write the credits as you do the experiment. And fifth, of course, have fun.